Hello, welcome to Revision Week 24. This week we're looking at Paper 2 and we're looking at algorithms, and that includes computational thinking, trace tables and flowcharts. As always, make sure you have your revision sheet in front of you. We will be completing some of the questions together today, so make sure you have a pen ready. Okay, so computational thinking, Paper 2. What is computational thinking? Well, basically, computational thinking is the process of taking a complex problem, understanding what the problem is, and then coming up with a solution to it, developing a possible solution. So, computers can do lots of fun things and amazing things to solve problems, but you need to be able to understand the problem itself so you can solve it. So, taking a problem, understanding what the problem is, and then developing a solution to the problem. There are three main techniques that you need to know about to apply computational thinking to a problem for GCSE. There is decomposition, which is breaking a problem down into smaller, more manageable parts, particularly if it's a complex problem, breaking a complex problem down into smaller, more manageable parts or problems. Abstraction, focusing on the important information only and then ignoring the irrelevant detail. So focusing only on the important information. And then algorithmic thinking, coming up with a solution, a step-by-step algorithm to solve the problem. So have a look at this. Decomposition. Decomposition is breaking a complex problem into smaller, more manageable parts. Have a look at this one. Imagine you had to travel from Plymouth to Paris in France. This could be considered quite a complex problem. How are you going to do it? There are lots of different things to consider. So to decompose this problem, you might want to think about the types of transport available, the cost or money available, how much money do you have, the roads available, times of boat crossings, weather conditions, time of day, number of passengers, how much time, and even things like any passenger restrictions or health conditions, such as is the person pregnant or ill? Can they travel by different means? All those are things you'd have to consider before solving the problem, breaking the problem down into smaller parts. Abstraction. What is abstraction? Abstraction is focusing on the important information and ignoring the irrelevant detail. So for this bit, make sure you've got your sheet in front of you. Complete this with me on the sheet. Abstraction is focusing on the important bits. In this example here, we have a map of Coombe School. So think, what has been focused on here? What has been included? Well, we've got the shape of the buildings, the basic building names, the basic layout. And think, what has been removed? What irrelevant detail has been removed? Well, there's no colours, there's no grass or green areas, there's no people or animals. Objects such as bins, benches have all been removed because they are not relevant for a diagram of the school, the layout of the school. So we focused on the important information and we've ignored or removed the irrelevant detail. Write this on your sheet now. Okay, and the final stage, algorithmic thinking. Once you've broken the problem down, you've abstracted it, coming up with a solution, a step-by-step algorithm to solve the problem. This is algorithmic thinking. There are different ways you can represent this. You could use pseudocode, which is written code to represent the solution. It's basically like a fake programming language code, or using real code as in the exam. Or you could use a flowchart to represent it in a visual way. So different ways of representing the solution to the problem. So make sure you've completed this on your sheet now. This section should now be filled in. And checking your answers. Computational thinking, taking a complex problem, understanding what it is and coming up with solutions. Abstraction, focusing on important information. Decomposition, breaking a complex problem down into smaller parts. And algorithmic thinking, developing a solution step by step. And of course the section which you should have filled in for abstraction. Okay, moving on. So now we know what computational thinking is, let's have a look at particularly the algorithmic thinking flowcharts. So a flowchart is a graphical way of showing an algorithm using symbols and lines, with different symbols used to represent different events or things in the flowchart. And the lines represent the direction the program is going in. So one skill you need to be able to do is identify what a flowchart will do in the exam. Have a look at this one. We're inputting the temperature, then depending on what the temperature is, it will give different outputs in this flowchart. So imagine, if the temperature was 30, what would be output? Temperature is 30. Is the temperature over 25? Well, in this case, yes, it's 30. So we go here, and the output's going to be wear shorts. What if the temperature is 12? Input temperature, is it over 25? No. Is it over 16? No. Is it between 10 and 16? Yes, true. Take a jumper. 2, input temperature, is it over 25? No. Is it over 16? No. Is it between 10 and 16? No. So the result, false, is take scarf. And finally, temperature equals 20. Is temp bigger than 25? No. Is temp bigger than 16? Well, yes, 20 is bigger than 16. So true, we wear a t-shirt. So all you're doing is taking the input you're given and working out, using the flowchart, what output, what solution would it give. So there are different symbols you'll notice that are used in the flowchart that you need to know for the exam. At the start and the end, we have a terminal. So start and at the end of the diagram to show the flowchart is started and stopped. Anything where you're calculating something, maybe like adding something to the total or working something out, is a rectangle, a process box. Anything where a decision's being made, such as the number of weeks left is bigger than 5, or temperature greater than something, that is a decision, a diamond, and there are 2 outputs, yes, no, or true or false. Inputs or outputs, such as someone typing something in or printing something out, is a parallelogram symbol. And possibly you might even have a subroutine where it calls a different part of the program. It runs a different program. That is a subroutine box. So that would run a completely separate flowchart if it got to that. And of course the arrow which shows what direction the program is going in. Okay, so on your sheet, just do this section here. Draw the symbols for each of these. Pause the video, do this now. Okay, checking your answers. You've got your start, your rectangle for your process, your parallelogram for your input-output, your rectangle with 2 lines for your subprogram, and your decision is a diamond, however it's got 2 lines coming out. Yes, no, true or false. Okay, final challenge here on this one, flowcharts. I've given you a space here and a little challenge to draw a flowchart. It says draw a flowchart that asks the user to input their age, and then if the age is 18 or over, it outputs come in and runs a subprogram called order drink. Otherwise, it outputs too young. Look for the key words here: outputs, input, subprogram. So do this with me. Complete this on the sheet. So firstly, we've got our start at the start of the program. It doesn't say that, but we know there's a start at the beginning, a terminal box. I've got my input for age. So all you have to do is literally input age. We then got a decision. It says if the age is 18 or over, so age greater than or equal to 18. Okay, we can do this semi-graphically and semi-diagonally with words here, and then 2 lines coming out, yes, no. If they are over 18 or more, it says output a message saying come in, so our parallelogram box, come in, and then run a subprogram called order drink. Well, look, Here's my subprogram. I don't know what that would do. That would run a completely separate program, subprogram, flowchart somewhere else. But that's all I have to do for this. Otherwise, if they are not over 18, output too young. And of course, we've started the flowchart, so we have to end the flowchart. So it just links into an end box at the end here. Okay? Unless it was a loop where it kept iterating around, it should normally go into an end box at the bottom. Checking your answers, correcting, making sure you've got the correct flowchart. And finally, trace tables. Now this technically comes under sort of testing. However, because we are talking about writing algorithms, I've included it in this video. So what is a trace table? So you could get asked to complete these in the exam. Complete this with me on the sheet now, please. A trace table is a way to test short programs by running through each line of code. You are literally running through each line of code and recording the values of variables and outputs in a table. So you run through the code and you record the values at each line in a table. It's very helpful to find logic errors in a program because you are tracing through to see what values variables have at different points. So have a look at this example I've given you here, this program. We're going to complete these together, okay? If you want to try and do it yourself, pause the video, do it yourself, and then check. So my program here says for x in range, x being a variable, 1 to 5. So remember, it's starting at 1, stopping at 5, but not actually including 5 in the Python version. Y equals x times by 3. If y is bigger than 10, it says big, else print small. Well, let's try this together then. So the very first line of code is going to be line 1, and x on line 1 the first time around is going to be 1. So line 1 and x is 1 on the first time around. Then we go to line 2. On line 2, y is x times 3. Well, x is 1, so 1 times 3 is 3. Then we go down to line 3. If y is bigger than 10, big, else print small. Well, y is not bigger than 10 because it's 3, so we don't run this. The next line of code to run would be line 6, print small. So line 6 and print small. We then go back in our loop again to the start of this program. So we go back to line 1. This time, x is not 1, it's 2. It's incrementing onto 2 in our loop here. And now we go to line 2. Y equals x times 3. Well, 2 times 3 gives us 6. Then we go down to here. If y is bigger than 10, print big. No, y is not bigger than 10. It's 6. So actually, we still go down to line 6 and we print small again. Going around again, back to line 1. This time x is 3. 3 times 3 is 9 on line 2. 9 is still not bigger than 10. So again, we output small. And on the fourth iteration going round, x is this time going to be 4. 4 times 3 is 12. Oh, look, on line 3, if y is bigger than 10, y is now bigger than 10. So we go line 4 and print big. And because the loop is 1 to 5, remember we stop when we get to 5, so the loop then finishes. So essentially we've gone small, 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 and it's gone over 12, and then it's printed out big. Checking your answers on your sheet, making sure you understand what we have done. Replay that if you need to understand. Okay, as always, go to revision, LearnCodeIn, revision quiz 24, check each question, make sure you mark and recorrect if needed. You should get 100% by the end of this quiz. Good luck and see you in class.